Hey guys, welcome to another video. Today's learning objective is to use the form y equals mx plus c to identify parallel and perpendicular lines. As usual, feel free to skip to any part of the video if you want to kind of consider some worked examples. So let's get into it. What do we need to know to approach this, and what prerequisite knowledge do we need? This idea about y equals mx plus c is really important. If you can remember what in this form what the M stands for and what the C stands for, you can probably remember the stuff we talked about in previous videos. Just as a check, M stands for the gradient, and that's what you effectively plug in the gradient, and C is where you plug in the y-intercept. As I've said before, this form isn't the only form of for an equation of a straight line. It's just a very useful form which we consider because it easily allows us to see the gradient and the y-intercept, which, as I've said before, are the two important factors when it comes to determining what a straight line looks like. So we've got these terms here, parallel and perpendicular. And perpendicular is actually something for higher only, so just watch out for that. Okay, so if you've got a line like this, right, for example, and you have another line which is just moved up, for example, the same line but moved up, or perhaps even moved down, what you then have are parallel lines. And all parallel lines are simply lines with the same gradient. I.e., in this form, y equals mx plus c, they'll have the same m. That's that's all there is to it. And maybe a bit about why they're interesting and some interesting properties they have. Well, with parallel lines, they'll actually never meet because if you think about it, for example, if we say this is the line y equals x, and this is the line y equals x plus 1. Well, we know the parallel because the gradient is 1 for both of these. And you can see why they'll never meet because whatever the value of y for this line is, y equals x, whatever the y is, for example, let's say, this is, let's say 4, and this is, of course, 4. Well, if this is, then this line, the value here will be 5, because it's, y equals x plus 1, which is 4 plus 1, which is 5. And so this line will always be, y equals x plus 1 will always be above the line y equals x, and so they'll never meet, so that's perhaps a useful property that we might want to know. Just as a quick check in terms of worked examples, or the lines say y equals 14x plus 7, and the line y equals 12x plus 8, plus 7, let's say. Are those parallel? Well, no, they're not, because the gradients are different. The gradient of this, you can say, you might say no, the gradient for line 1, so if we say that's 1, that's 2, is 14, whereas the gradient for line 2 is 12, and 12 does not equal 14, therefore not parallel. So that's just a quick thing to do. Let's try another one. If you can pause the video this time around and perhaps give this a guess. Y equals x plus 7, y equals x plus 9. And clearly these are parallel, they have the same gradient. I'm not going to bother writing it out. One thing to watch out for, if sometimes, for example, if you have something like y is equal to 2x plus 12, 2y equals 2x plus 12, well, this isn't in the form that we usually have it in the y equals mx plus c form. We have to divide everything by 2 to get into the form that we want, so we get y equals x plus 6. And so clearly these are parallel now, but it's less obvious in this case. So that's just something we need to watch out for. But yeah, that's parallel lines, and that's all there is to it. Just looking at the gradient and seeing if they're the same. Now turning to perpendicular lines, which is a higher topic. So if we look here, these are two lines which are an example of a pair of perpendicular line. Of course, you need at least two lines for them to be perpendicular. a line cannot be perpendicular to nothing. It needs to be perpendicular in relation to another line. And all that means is that kind of where they meet, the gradient of one is a kind of, so not the gradient, sorry, the where they meet, they're kind of 90 degrees to each other. They meet at a right angle, and kind of that's basically all there is to the kind of geometric definition of perpendicular lines. What this actually does result in is kind of, it means if the gradient of this is, say, m, so if we say, this is y equals mx plus c, the gradient of this line is going to be y equals minus 1 over m x plus, we'll call this c dash to represent another c. And that's kind of just a property of perpendicular lines. I'll include a proof in another video, which is kind of completely optional to, if you want to understand where this comes from, and instead of just, taking my word for it. But, the result that you do come out with is that for perpendicular lines, if the gradient of one line is m, the gradient of the other line is its negative reciprocal, which is minus 1 over m. So if I was to ask you to find, so say you've got the line y equals 7x plus 12. If I was to ask you to find a line that is perpendicular to this, you might say one line that is perpendicular to this is minus 1 over 7x plus, say, 15. Because if you think about it, there's actually kind of an infinite number of lines that are perpendicular to y equals 7x plus 12. So, say, let me actually switch to an easier example. Say I'm looking at y equals x. And say this line is y equals x, right? And so, of course, this line is perpendicular to it, of y equals minus 1 over 1, x, plus, I don't know, this is probably what, plus 8 maybe? So y equals minus x plus 8 is, say, perpendicular. But at the same time, kind of the line y equals minus x is also perpendicular. And this, kind of down here and here, so there's actually an infinite number of lines that are perpendicular. So kind of, you won't be asked to find the line which is perpendicular, you can be asked to find a line which is perpendicular. So for example, if you have, say the line y equals 15x plus 22, and the question is, find a line which is perpendicular to this. You can say kind of, one line that's perpendicular to this. You can do, you can say gradient equals 15, therefore gradient of perpendicular, you can just shorten that to perp line, is equal to minus 1 over 15. And then you can say, therefore, one kind of example is minus 1 over 15, x plus 12. And perhaps you might actually be asked to find the kind of the perpendicular line that goes through a point. So say if you're asked to say, find a line perpendicular to, I'm not going to write out the question, so find a line perpendicular to, say, y equals, I don't know, 32x. No, that's actually a bad number. I think of say a half x plus 12, which passes through the point, say, I don't know, minus 4, 8. Okay, so you say gradient. So you can say gradient of line is then of this line of line 1 is a half. So therefore, what's the gradient of the line perpendicular to this? Of line perp? Well, that's going to be, so that's a half, so you do the negative reciprocal, so you can, or which is minus 1 over that number, so minus 1 over a half, which is minus 2. And it passes through this, therefore, equation of perp line is equal to y equals minus 2x plus c. And we know it passes through this point, so we go right, 8 equals minus 2 times by 4 plus c. 8 equals, minus 2 times minus 4, which is 8 plus c. So c equals 0. Therefore, the line is y equals minus 2x, and that's it. So that's kind of another example of where you might be asked to find a line perpendicular but passes through a certain point. And this is kind of the same logic as we, I think 2 lessons ago, where we talked about having the gradient of a line and knowing a point that goes through. What you do is you look at the original line, you know the kind of the property for perpendicularity, which is kind of, it's going to be the negative reciprocal of the gradient. you stick that in to find the gradient of the perpendicular line, and then you know it passes through this point, and then you can just plug that in into that equation there. So kind of there were a few things mentioned there. For the foundation tier, it was kind of parallel lines and talking a bit about that. But for higher tier, you also have to know about perpendicular lines. As I mentioned, I just kind of told you the condition. If you want to see kind of a geometric proof of this, I've made kind of a bonus video, which is completely optional, but I recommend you to check it out if you want to understand the intuition behind it. But yeah, hopefully that made sense, and I'll see you guys in the next video.